Now we are discussing the project which is related to a soil moisture sensing. Normally, in our villages or in the homes, in the backyard of our homes, when we want to water the plants, we will see the moisture level that is at the plant. In this project, irrespective of whether the human being is available or not, we are making the use of the moisture sensor. So when this moisture sensor is detecting the moisture, when the moisture sensor is detecting the adequate amount of the water, then automatically the motor will be turned off. There will be no supply of water to this soil. When this moisture sensor is detecting dryness, moisture level content is very less, then motor is automatically turned on and that water will be sent to the soil. In this project, we are making the use of this moisture sensor, and I am using two indicators as of now. One indicator is I am using the LEDs and second indicator is LCD display. In this LEDs, one LED will be turned on when the moisture level is high, means when the soil is wet, and another LED is on when the moisture level is low or when the soil is dry. For example, I am taking this soil moisture sensor in the water. At this position, the land is wet, the soil is wet, so one LED is turned on. Now I am removing this. Now the soil moisture sensor is sensing the dryness. Another LED is turned on. Again I am giving the water to this, so it sensed the moisture and another LED is turned on. So this is one indication, but we are not satisfied only with this indication. We are taking the use of LCD panel here. In this LCD panel, whenever the motor is turned on, that display will be shown to us. Now, you can observe here, there is a wetness that is observed by the moisture sensor. So the moisture sensor senses the wetness of the soil, so motor is turned off. There is no requirement of the motor. Now the soil moisture sensor is detecting the dryness, so immediately motor is turned on and the adequate amount of the water will be supplied to the soil. In this way, we will automatize the motor working. When the moisture level is high, there is no motor requirement. When the moisture level is low, then automatically motor will be turned on. We will see the live demonstration. Now you can observe here, the soil moisture sensor is kept in the dry land. So when the soil moisture sensor detects the dryness, automatically the motor will be turned on. We will place this here. Automatically, after sensing the moisture, immediately the motor is turned off. Now, for example, I am placing here somewhere. Now, after detecting the moisture level, it is automatically turned off. Now, here I have placed this land. Here, now the entire land is wet. The motor is turned off. Similarly, in this project, we are using a simple 5-volt submersible motor. When the soil is a very big land, in that soil we can use the more capable motor, submersible water, in such a way that it will give the water to the entire land. Now we are discussing the components that are used in this project. We have used a soil moisture sensor. This soil moisture sensor is consisting of two conductive plates. These two conductive plates are behaving like two metallic plates of a capacitor. Here this is a dielectric material. When we place the soil moisture sensor in the soil, when it is detecting the adequate amount of the water, the permittivity, the dielectric medium which we are keeping in between these metallic plates, the permittivity is being changed. The equivalent capacitance value is being changed. So the equivalent voltage the moisture sensor that is sending to this controller is also being changed. We are using a controller here. Here we are using one LM393 comparator, and to adjust the sensitivity of this sensor we are using one potentiometer. This soil moisture sensor is having the capability to give the output either in the analog or digital modes. We are taking the analog output. We are giving this analog output to the Arduino, and when Arduino is receiving this analog output, based on this analog output, we are setting a threshold point. If Arduino recognizes this threshold point is reached, then automatically that particular pin, the digital output pin, will be activated. This digital output pin we are connecting to the resistor, forward by the resistor is connected to the base of the BC547 transistor, and the collector of the BC547 transistor is connected to the relay. We are giving one battery to give the supply to this relay coil. So when the soil moisture sensor is detecting there is no adequate amount of wetness here, immediately the threshold point it recognizes. When it is less than, we will write the program here in this Arduino. Then we will dump the program in this Arduino. Based on that, it will recognize, it will give the high voltage at the digital output pin. Immediately the relay coil which is turned on, and based on that the submersible motor will be turned on. When the wetness is high, automatically here at the output the voltage is low. Because the output voltage is low, immediately the motor will be turned off. We are using two LEDs here. We are connecting the two outputs immediately to these two LEDs. We have already seen when one LED is on, that is indicating the motor is on. When another LED is on, that is indicating another motor, means motor is turned off. In this way, we can do this project by using the soil moisture sensor and Arduino and submersible pump. Similarly, we can connect the one digital output to control the LCD panel. We have already seen in the Arduino tutorial how to display the text in the LCD panel. So when motor is off, automatically the text will be displayed as motor off, and when the motor is turned on, automatically the text will be displayed as motor is turned on. This will give an additional advantage to us. The display gives the chance to the user to monitor whether the motor is on or off in the real-time situation.